Imagine waking up on Mars, the rust-red landscape stretching out before you. Could this be our future home? It's a pretty cool idea, and it's something that scientists and engineers have been exploring for a while now. But before we can even think about setting up a human settlement on Mars, we need to figure out how to get there safely. It's not like we can just hop on a bus and drive to Mars, unfortunately. The distance between Earth and Mars is about 140 million miles, which is a really long way. To put that in perspective, when the Apollo astronauts went to the Moon, they were only about 239,000 miles away from Earth. So Mars is like more than 500 times farther away than the Moon. That's why we need some serious technology to make the trip possible. One of the biggest challenges is propulsion. How do we get a spacecraft to travel that far, that fast? Right now, the fastest spacecraft ever built is the Parker Solar Probe, which can reach speeds of up to 150,000 miles per hour. But even with that kind of speed, it would still take a spacecraft about 6-9 months to get to Mars. That's a long time to be cooped up in a small spacecraft, and it's not just the boredom that's a problem. It's also the radiation. Space is filled with all kinds of harmful radiation, which can damage both people and electronic equipment. So, we need to find ways to protect ourselves and our spacecraft from that radiation. One way to do that is with something called shielding. Shielding is like a protective blanket that wraps around the spacecraft, and it helps to block out the radiation. We can use all sorts of materials for shielding, like water or liquid hydrogen, which are really good at absorbing radiation. But shielding is heavy, and it takes up a lot of space, which is a problem when you're trying to build a spacecraft. That's why scientists are also looking at other ways to protect people and electronics, like using magnetic fields or inflatable spacecraft. These are still pretty experimental, but they could potentially be more efficient and lighter than traditional shielding. Another big challenge for a trip to Mars is life support. When you're on Earth, you don't really think about the air you breathe, or the water you drink, or the food you eat. But when you're on a spacecraft, all of those things have to be carefully managed. You need a system that can recycle air and water and waste, and also produce food. It's like a little ecosystem, and it's really hard to get it just right. Right now, we're using a combination of stored food and hydroponics to grow plants in space. Hydroponics is like a way of growing plants in water, rather than soil, which is really efficient and can produce a lot of food. But we're still working on how to make it all sustainable and how to make it work for a long period of time. So, let's talk about the actual trip to Mars. What would it be like to travel through space for 6-9 months? It's not just the distance that's a problem, it's also the isolation. When you're on a spacecraft, you're really cut off from the rest of the world. You can't just pick up your phone and call your mom or go for a walk outside. You're stuck in this tiny little spaceship with a limited number of people and limited entertainment options. It's like being on a really long road trip, but instead of stopping at rest stops and restaurants, you're just floating through space. And when you finally arrive at Mars, you'll have to deal with the Martian environment, which is really harsh. The atmosphere is thin, the temperatures are extreme, and there's radiation everywhere. But despite all these challenges, scientists are making progress. They're developing new technologies, like more efficient propulsion systems and better life support systems. They're also learning more about the Martian environment and how to protect ourselves from its dangers. For example, NASA's Curiosity rover has been exploring Mars since 2012, and it's given us a wealth of information about the planet's geology and its climate. We're also learning more about the psychological effects of long-term space travel and how to mitigate them. It's all pretty complex, but the idea of one day waking up on Mars and looking out at that rust-red landscape is what keeps scientists and engineers motivated to keep pushing forward. So what would it actually take to establish a human settlement on Mars and make it self-sustaining? Well, first and foremost, we'd need a reliable way to get people and cargo to the planet, which is no easy feat. The distance between Earth and Mars varies, but on average it's about 140 million miles, and it would take a spacecraft around 6 to 9 months to make the journey. That's a long time to be cooped up in a small space, and it's not just the physical challenges we need to worry about, but also the mental and emotional ones. Imagine being confined to a small spacecraft with limited amenities, and no chance of taking a walk outside for almost a year. It's a daunting prospect, to say the least. But let's assume we can overcome the transportation hurdle. What about the actual living conditions on Mars? The planet's atmosphere is thin, and the pressure is too low to support liquid water, which is essential for life as we know it. So, we need to create a reliable source of oxygen and a way to purify water or even extract it from the Martian soil. And then there's the issue of radiation. Mars doesn't have a strong magnetic field to protect us from harmful solar and cosmic rays, so we need to build shelters that can provide adequate protection. It's a complex puzzle, but scientists are working on developing new technologies, like inflatable habitats and in-situ resource utilization, which would allow us to use Martian resources to support life. One of the most promising concepts is the idea of a Martian greenhouse, where we could grow our own food and create a reliable source of oxygen. It sounds like science fiction, but it's actually based on some pretty solid science. By using the Martian soil and the planet's natural resources, we could create a closed-loop system where waste is recycled and resources are used efficiently. It's not just about sustaining life, but also about creating a sense of community and normalcy in a very alien environment. Imagine being able to walk into a Martian greenhouse and seeing fresh produce and plants. It would be a small taste of home in a very distant world. Of course, all of this is still largely theoretical, and we're still in the early stages of planning and development. But the progress we've made so far is promising, and it's giving us a glimpse into what a human settlement on Mars could look like. We're talking about a future where humans can live and work on another planet, and where we can expand our presence in the solar system. It's a future that's both exciting and unsettling. And it raises a lot of questions about our place in the universe. What would it mean to be a multiplanetary species, and how would it change our perspective on ourselves and our planet? These are questions that we'll be exploring as we continue to push the boundaries of space exploration and colonization. So, let's dive deeper into the concept of a human settlement on Mars. One of the biggest challenges we face is creating a reliable food supply. Since resupply missions from Earth would be expensive and logistically difficult, we'd need to find ways to grow our own food on the Martian surface. This is where hydroponics and aeroponics come in. These are methods of growing plants in controlled environments without using soil. They're perfect for a Martian colony because they're efficient and can be used to grow a wide variety of crops. Another crucial aspect of a Martian settlement is radiation protection. Space is filled with harmful radiation that can damage both human bodies and electronic equipment. To mitigate this risk, we'd need to build our habitats with thick walls that can absorb or deflect radiation. We could also use the Martian soil to create a natural barrier against radiation. This is because The soil contains high levels of iron oxide, which is a great absorber of radiation. By using local materials, we can reduce the need for resupply missions and make our colony more sustainable. Now let's talk about the psychological aspects of living on Mars. The Martian environment is harsh and unforgiving, with temperatures that can drop to 125 degrees Celsius at night. The atmosphere is also very thin, which means there's no air to breathe and no protection from the sun's radiation. This would take a toll on the mental health of the colonists, who would have to live in a constant state of isolation and confinement. To address this issue, we need to create a sense of community and connection among the colonists. This could be achieved through social activities and shared goals that would help to build a sense of purpose and belonging. As we move forward with the idea of colonizing Mars, we'll need to consider the long-term implications of our actions. We'll need to think about the kind of society we want to create on the Red Planet and how we can ensure that it's just and equitable for all. We'll also need to consider the potential risks and challenges that come with establishing a human settlement on another planet. But despite these challenges, the potential rewards of colonizing Mars are vast and could potentially secure the future of humanity. So what's next in our journey to the Red Planet? In our next video, we'll be exploring the latest developments in Mars exploration and the new technologies that are being developed to support a human mission to Mars. We'll be looking at the latest designs for Martian habitats and the innovative solutions that are being proposed to address the challenges of living on the Martian surface. Join us as we continue to explore the possibilities and challenges of colonizing Mars and discover what it would take to make humanity a multiplanetary species.